Okay, this is number 3 in the practice redox problems we did in class, and this is in acid. What is it? Sodium hydrogen sulfate. It's got a fancier name I forget for now. Oh well, let's balance this darn thing. Okay, so first thing you got to do is find the oxidation numbers. Okay, let's do that in red. Oxygen is -2. Remember, it's for each atom. 4 times 2, -2 is -8. The total has to equal to -1. So what does manganese have to be? Why, it has to be +7. So there it is, +7. HSNO3, H is going to be +1 pretty much all the time. Excuse me. Oxygen here has to be -2. And 3 times -2 is -6. Total has to be -1. We've got +1 plus what is equal to -1. So -6 and +1. So this has to be, what is that, +4? Yeah. That's +5. That makes sense. +4. And I like to circle the oxidation numbers. Okay. Circle them. Oops. I wrote on my desk. Oh well. -2 over here, oxygen, same thing, 4 times 2, -8. I like to do all my math on the bottom and all my oxidation numbers on top. This has to be +6. That looks good. +6 and -8, -2. Manganese oxide, I guess -2. -2 times 2 is -4. And this is a neutral compound, so this has to be +4. Very nice. Alright, let's see what's happening here in terms of oxidation and reduction. Manganese, +7, goes to +4. So that is gaining electrons because it's becoming less negative. Okay? And then let's take a look at hydrogen, nothing's happening. Oxygen staying the same. Sulfur goes from +4 to +6. So here we go. And that is going to be losing electrons. They're becoming less negative. Okay? So that is the oxidation. Alright, so let's do the half reactions. I like to start with the oxidation first. I'm not exactly sure why. Alright, here we go. So let's start out with HSO3 minus. Do not forget the charge. Circle it so you don't lose it. Gives you SO4 2 minus. Okay, looking good. Remember, the order for everything is everybody orders hot cakes. So you do your elements first. You do your oxygens using H2O. Then you do hydrogens using H+, and then you do your charge doing electrons. Elements first, except for hydrogen and oxygen. Sulfur one of those. Good. Now let's do oxygens. 4 oxygens here, 3 here. Let's add an H2O. Okay, looking good. Hydrogens here now. We have 1, 2, 3 hydrogens. Over here we need to add 3H+. Now we got to do the charge. Total charge on this side here is -2 and +3. That's a total of +1. Over here we have -1, because this is -1 and this is 0. Okay? So in order to get them equal, we can only add electrons. So let's add 2 electrons, and that'll give me a total charge here of -1. Okay? So that's balanced on the oxidation side. Half reaction. That's short for reaction, by the way. Merry Christmas. Alright, now let's do the next one. Let's do the reduction side. So, MnO4 minus goes to SO4 2 minus. Okay? No. MnO2. Alright, here we go. Seeing if you're paying attention. So this is, now we got the elements, Mn, good. Oxygens, H2O, we got 2 here, 4 here, add 2 H2Os. Now let's do the hydrogens, 4 hydrogens here, we're going to need 4 hydrogens there. Looking pretty good. Now let's do the charge. That is 0, which is nice. This over here, plus 4 minus 1, that's plus 3. So in order to make this equal to this, we have to add 3 electrons, total of 0. Okay? Everything's nice. Now we need to combine these. Well, the electrons that are given off in the oxidation have to match the electrons going in. So this gives off 2, and this gives off 3. So how are we going to make that balance? Well, let's multiply it. What's the common denominator here, or what is it, common multiple? I get it mixed up. It's 6. So if we multiply everything here by 3, that'll give us 6 electrons out. And if we multiply everything here by 2, that'll give us 6 in. And that's what we want. So let's do the math. Now let's stack them up. I like to just do the math and then put it all here and then let the dust settle at the end. So we got 3H2O plus 3HSO3 minus goes to 3 SO4, 2 minus, plus 3 times 3 is 9, H plus 3 times 2 is 6 electrons. Very nice. Now 2 times 3, well, we'll go, yeah, I was going to say go backwards, but why do that? 2 times 4 hydrogens is 8. 2 times that is 2 minus, and then on this side over here, 2 times MnO2, and then 2 times 2 is 4H2O. I mean, you could also just do the numbers here, but it looks messy. But so I like to do it like this. All right, let's see what we can cancel. Let's use the blue marker. All right, here we go. So, hydrogen ions. We got 8 here, 9 here. Ooh, that's nice. Let's cancel that so we have 1 hydrogen ion. Oh, the most important thing, do the electrons cancel? Yes, they do. Yay. And then H2O molecules, we have 3 here and 4 here, so we can cancel that. We get 1. All right, let's let the dust settle. See what we got. We've got HSO3 plus 2 MnO4 goes to 3 SO4, 2 minus, plus 2 MnO2 plus 1H plus 1H2O. Okay, moment of truth. Is it all balanced? Let's take a look. Oh, look. I forgot my 3 here. See? This is a good step. I only noticed that because I get, oh, I have 3 S's. So I need to have 3 of these. So 3 S's are good. This is always the important step to double check. All right, 2 MNs, 2 MNs. Yes. 3 H's. Is that right? 1, 2, 3 H's. Good. 8 oxygens plus 9 oxygens. What was that? 17. What was that? 12. 13, 14, 16, 17. It all works. Now check the charge. Total charge of 3 times negative 2 is negative 6. Over here we've got negative 2, negative 3, because it's 3 times negative 1. And that is going to be, oh, this is negative 6 plus 1 here, so that's plus 1 is equal to negative 5, and this is equal to negative 5. All done. Okay, there it is. There's your balanced equation. And usually at this step you add the states of matter or whatever you got. And here's a little good luck cat for you. Good luck. I don't know why I'm doing that. It's fun.